Hey guys, Coach Tucker. We're going to go through and work some quadratic word problems that are written in standard form. This is probably the only lesson I'll do with this video. This could be a really short video, so let's get to it. So it says an object is launched from a platform. Its height in meters, x seconds after the launch, is modeled by the equation given. What is the height of the object at the time of launch? Okay. So like with all word problems, we got to sit down and think about what's the problem asking and what things are being referenced. So what is the height of the object? So if you think about it, height, we're talking about a height here, so the thing's being launched, it's like this. Height is going to be the functional value, it's going to be the y. So we're looking for a y. So when do we want the y? At the time of launch. So x must be time, and it's time because it says it here, x seconds. So when would it have launched? What, 0 seconds? So what is the height at 0 seconds? Well, then we just figure it out. So let's actually get our sketchbook out here. Let's get our sketchbook out here. There it is. All right. So we're figuring out x is equal to 0. So h of 0 is equal to -5 times 0 squared plus 20 times 0 plus 60. Well, hopefully you're realizing now you didn't have to do all that, Coach. This becomes 0 plus 60. That's just 60. That's because it's the y-intercept, right? The y-intercept is always the starting value. So what is the height of the object at the time of launch? 60 meters. There we go. Let's go through a few more. Say a certain company's main source of income is selling cloth bracelets. Almost said the cloth. No. The company's annual profit in thousands of dollars as a function of the time of a price of a bracelet in dollars is modeled by, we have the equation. What bracelet price should the company set to earn its maximum profit? So now remember, let's pull up our sketchbook. We're going to have to do a little work here. So P stands for profit, right? We have P here. P is profit. The X stands for, as a function of the price, X is equal to price. Okay, so what should the price set to earn its maximum profit? Well, I want you to notice this A is negative. That means it's going to have that type of relationship, right? It's going to go up and then down, which makes sense. It should go up in price and down in price over time the profit will go up and down based on the price. There's going to be a certain price where it's perfect, and they sell a ton of it. They make it too expensive, they're going to sell less. They make it too cheap, they're not going to make as much profit. They got to find the right one. So how can we do that? Well, we're looking for the X value. We want to know, what is the X value at the vertex? It's the axis of symmetry. X equals -b over 2a. So X equals -b over 2a is equal to, that's a negative there, so -16 over 2 times -2. Now, negative times negative makes positive, and that's key. And here's why. We're talking about price. Price is supposed to be positive. It can't be negative. So if you work this problem out and you get x being a negative, you know you did something wrong because the context of the problem. So we have a negative times a negative, or a negative over a negative makes a positive. So we have 16 over 4. That's just $4. So at $4, they're going to make a maximum profit. What is that profit? Well, you would just plug in 4. Now, obviously, we don't have to do that. That's not something we're required to do. But we could if we wanted to. We could plug in 4 into there, and we could find what profit would be. But we were not tasked to do that, so we will not. Okay, so Elaine throws a stone off a bridge into the river below. So the stone's height in meters above the water, x seconds. After Elaine threw it, is modeled by that equation. How many seconds after being thrown will a stone hit the water? So again, let's pull up our sketchbook. We got to think about in context of the problem. What are we looking at? Things like that. So here's the water, right? And he's over here somewhere. He's off a bridge, right? And he throws it. That's what we want to know. We want to know one of the zeros. So we're going to have to solve for 0. So 0 equals negative 5x squared plus 10x plus 15. So this is where you get to be kind of creative. What way do you want to solve this equation? Do you want to solve it by square roots? Can't do it. Factoring, completing the square, or quadratic formula. Now you may be looking at that a going, ooh, a's negative. Let's use quadratic formula. Not so fast, my friends. I'm going to use factoring. Here's why. Because we have an equation and I have a greatest common factor, why don't I divide both sides by negative 5? 5 is the greatest common factor over here, isn't it? The GCF here is 5. But I also want a to be positive. And right now it's negative. So if I divide both sides by the greatest common factor and the negative, I get 0 equals, this becomes a positive x squared. This becomes a negative 2x. This becomes negative 3. Look how easy this is. What factors of 3 subtract to be 2? 3 and 1, right? So boom, boom. 3 and 1. They're both different. This gets the negative. Now we use the zero product property. So x minus 3 equals 0. X plus 1 equals 0. So x equals 3 or x equals negative 1. So we have two answers. How do we know which one is which? Remember, x is time. So it crosses at negative 1 and at 3. Which one would be our answer? Well, this one will not work because we're going back in the past. And you're not allowed to do that. You have to always keep going forward in time. So 3 is the answer we're looking for. So 3 seconds. Okay. Again, go through. You got any questions to ask me? What's this last problem? Here we go. Rui is a professional deep water freediver. His altitude in meters relative to sea level x seconds after diving is modeled by that equation. What is the lowest altitude Rui will reach? He's doing this, right? They want to know what's the lowest altitude. They want to know the y. Can you find the x? Yep, negative b over 2a, right? So this is negative b. So negative of negative 10 over 2 times a, which happens to be 1/2. Negative negative makes a positive 10 over 1, which is 10. Now that we have that, is this our answer? No, this is the x value. We're looking for the y value. You got to plug it in. So d of x, or in this case, actually, d of 10 is equal to 1/2 10 squared minus 10 times 10. 10 squared is 100. Half of 100 is 50. Minus 10 times 10 is 100. 50 minus 100 is negative 50. That is really close to our answer, but it's not going to be entirely correct. Why is it not correct? Lowest altitude, meters relative to sea level. Yes, the x value is negative 50, okay? That's the thing. So if you were to find this value here is 10, negative 50. That's the point of that. So the y value is negative 50. However, the answer is positive 50 because we're already stated lowest altitude he will reach. So they're already saying that it's going to go below sea level. Anything below sea level is considered to be negative. But you don't dive negative 50 meters. You either dive 50 meters or you don't dive 50 meters. Remember, distance cannot be negative. Direction can be negative. In this case, we're already understanding that we're going negative. So, or at least that's what I'm going to say. I'm going to say we go, let's put negative 50 and see what it says, just so you can see. Oh, nope, it was right. Why was it right? Oh, relative. My bad. I thought it was already assuming below. So, there you go. So make sure you're paying attention to that. If it says below, then you don't have to put the negative. But if it says relative, so in relation to sea level, where is it at? Well, negative tells you it's below it, okay? So make sure you understand that. And I kind of did that just so you can kind of see, wait, hold on, coach, you were wrong. No, we're good. So if you got any questions, throw a comment. You can go to the YouTube page, throw a comment on it. Yeah, that's it. Thanks, guys.